Great. Yesterday we looked at focus yesterday was on our net force and our applied force when we were using a rope or a string. We referred to it as tension force. Okay? And then we would subtract whatever the force was that was working against it. Today's focus will again be on my net force. It may be tension, maybe an applied, but our focus is on this guy today. Our force of friction and using the coefficient of friction to find it. Now, if an object rests on a flat surface, the force of gravity working down will be the same as the normal force working up. To find my force of friction, I take the measure of the normal force and I times it by the coefficient of friction. Now the coefficient of friction is the value that's given based on the two surfaces sticking together. Okay, so obviously when you stop a car on ice and you stop a car on asphalt, the car stops at different distances because the coefficient of friction between the two surfaces are not the same on the rubber. Can you sit still for a little while? Okay? So we're going to start looking at question 2 on 164. The driver of a 2,000 kilogram car applies brakes on a dry concrete roadway. Calculate the force of friction between the tires and the road surface. Alright. So like I just said, in order to get the normal force, when we're talking about a horizontal surface, it's going to be the same value as your force of gravity. Of course it works in a different direction. So we make one positive, one negative, whatever. Okay, so then I have 2,000 times 9.8, which is going to give me 19,600 newtons. Okay? So then the next thing I need to find, in order to find the force of friction, if it's not given to you, it'll be on that chart. So 19,600 newtons times the coefficient of friction of what? What are we looking for here? Go to your chart on the page before. Okay, at the top of the page. Look at that chart. What are we talking about here? Dry concrete, Brittany. So which one is it? Okay, so what's the value?
1.02.
That's right. 1.02. Again, it's a coefficient, so it doesn't have units on it. So therefore, the force of friction is 19,600 newtons times 1.02. What does that work out to? What is it? 19,992 newtons. Okay? Questions about that? Okay, force of friction is not something we haven't already looked at. It's new. The only thing that we haven't really worked much with is this guy right here. That's the coefficient of friction. So focus today on your questions will be on the coefficient of friction. Right? 20 kilogram box. Being dragged across a floor with a force of 100 newtons. The force is applied at an angle 40 degrees above the horizontal. If the coefficient of kinetic friction is 0.32, what is the acceleration of the box? Alright, so first thing we do. Write that out. We should always start by drawing our diagram as well. Okay, so what's the one thing that we learned last section about finding our applied force? Where's your applied force always?
Horizontal.
In this case, it's horizontal because that's the direction in which it's going to move, right? So, find your force applied first.
76.604. 76.604.
Thank you. 0.4 newtons minus my force of friction. Well, what's my force of friction? So here's an interesting one. Okay. All right. Now, this is completely new to you. This is different than what we did last unit, so I want you to watch. First of all, if this box was just simply sitting on the ground, not being moved, just simply on the ground, how do I find the force of, the normal force affecting it?
Force of gravity.
Okay, so that's the first thing I want to do, is I want to find the force of gravity. So what's the force of gravity in this case? What is it? 20 times 9.8? So 196 newtons. So my normal force acting up is 196 newtons. Okay? So I'm going to just get rid of this for a second. Now, here's the one thing that we did not take into account last unit that we are going to now. This box also has upward motion because of the pull on that rope. Okay? So this box is going to lift up a vertical force. So now you need to find the vertical force. So take the sine of 40 and times it by 100.
64.279.
Okay. So if I'm lifting it up a little bit, does the floor still present 196 newtons on a box? No. Does it have more or less?
No.
It has less. So in this situation now, I have 76.604 newtons minus my normal force now. How much is my normal force?
196.
No.
Yes.
That force is 74. Isn't it?
This is 74?
I got 64.
Go to degrees, Kelsey, go to degrees.
Oh, right, then you do it
Okay, thanks.
Sorry.
Okay,
131.721.
131.721. And we have to multiply that by our coefficient of friction. I'm going to divide all that by 20.
2.10.
Okay. So, last unit, we were not concerned about this vertical force. All we were looking for is this. And we used that force in order to get our applied force. The force of friction was given to you. Now that the force of friction is not given to you, and you have to find it using the normal force, you have to take into account that there's this here. Now I want you to think about the question that was on the test about shoveling. If I'm pushing a shovel or pushing a lawnmower, this force, does it work with or against the normal force? Is it? Against it, because I'm pushing down. So therefore, there's going to be more force acting on it here. So let me do this for you right now. Let's draw a diagram of what's happening here. I have my mass of 20 kg. So the forces acting on this guy are as follows. Force of gravity. Force normal. I'll call this force vertical, just 'cause. Also acting on it. Alright? Because you are lifting that rope up, or whatever he's holding on to, that handle, you're lifting it up a little bit off the ground. Okay? Force applied, and force of friction. So those are all the forces acting on that object right now. Okay? The applied force and the vertical force you get based on your triangle. And then you have to apply them to the question. Okay? If this was a lawnmower question where you're pushing on the handle, or a shovel question where you're pushing on the handle, this force right here would be downwards. And it would be opposite, then this combined would give you your normal force. So if you're lifting it up, your normal force is lessened. If you're pushing it down, you've got a greater normal force. Okay? And we haven't dealt with this. This is what's new today. Something that we didn't do last unit. Okay? Questions?
So when, say you're pulling a wagon in
Mm-hmm.
this question, so your V or FV will go up, would you subtract it so that it is a lesser force?
Yeah, okay. Without that there, my force of gravity and my normal force are the same, right? The
Okay.
normal force is the amount of force the ground is pushing on this.
Right.
But if I pick it up slightly, then the normal force is less.
But the
The ground, the force of gravity stays the same.
Yeah,
Yes.
okay. But then if it were the other way, you're pushing
Okay,
along
let's do it
that.
like this then. So to answer your question, my normal force in this case, I don't have this written down anywhere. Oops. Because I don't want you to write it down. Oh, jeez. That. And if you're pushing down on the handle, so this is going up, this is pushing down. That's basically what it essentially happens here.
Okay,
Okay? Does that make sense to you?
yeah, it does.
Okay? So your normal force, if you're pulling something and you're pulling it up on an angle, your normal force is your force of gravity minus your vertical force. If you're pushing it down, like a lawnmower or a shovel, the force of gravity plus the vertical force gives you your normal force. Okay? Now, going back into, we have one more question here to do. And it's the incline question again. So this one actually was on your test as a bonus. A boy on a toboggan is sliding down a snow-covered hillside. The boy and the toboggan together have a mass of 50 kg. The slope is at an angle of 30 degrees to the horizontal. Find the boy's acceleration if there's no friction and if there is a coefficient of friction of 0.15. So, those of you that got that wrong on the test, forces acting on this are as follows. Right? What's pulling them down? Gravity. That gravity force, that gravitational force takes them straight down here. And that force of gravity is 50 times 9.8, which is 490 newtons. The normal force. The normal force makes a right angle with the surface here. Goes up this way, like that. But if I draw it down, it's right there. So it's one of the things we have to figure out. The applied force is in the direction of motion, so it's parallel to the slope. And again, I draw it down here. Now this green guy right here and this red, they make a right angle, so it also makes a right angle right there. You have to know how to draw this. This is the only kind of question that has this triangle below. You need to know this. I stressed that before. There's no other way to do this question in terms of drawing that triangle other than the way we've got it here. Okay? 30 degrees right here means that this is 30 degrees right there. So now I want to calculate to solve for this. So I need my applied force and I need my force of friction. So let's just focus on the B part. So the first thing I want to do is find my applied force. What's my applied force? Sine 30 times 490. What is it?
245.
245. I'm done without a calculator. Alright. Cos 30 by 490.
$424.352.
A little louder, please.
$424.352.
We agree? Yeah? Good. Okay? So what's my acceleration equal to? 245 minus my normal force, 424.352, times my coefficient of friction, which is 0.15. All divided by 50.
That's exactly what we're supposed to do in the test too.
Now because you have a subtract on top, you probably should use brackets.
I got 3.797.
Yeah, that's what I thought.
Here's your acceleration. Okay? We okay?
Where did 0.15 come from?
given to you in the question is the coefficient of kinetic friction. Look at the B part.
The one that tested wasn't-
Coefficient of friction, okay.
Okay.
All I tested wasn't the coefficient, it was just the friction, right? Yeah.
Okay. Any questions about this guy? No? Okay, I want to keep going today. We'll look at question 2 and 3, the next two problems. Actually, 1 and 3. On projectile motion. Again, we've somewhat dabbled on this already, but I'm going to show you okay. A rock is thrown horizontally 10 meters per second from the top of a cliff 122.5 meters high. How long does it take the rock to reach the ground? Okay, so we are changing gears drastically here. We're not working with force at the moment. We're working with projectile motion. Now, I want to talk about this in terms of without adding the cliff into it. I'll add the cliff into it after. But here's what happens. Let's say I'm standing on the ground here and I throw a rock up and it leaves at 10 meters per second. Okay? Oh, this one's thrown hard. Sorry. You know what? I can't do it this way. I'm going to backtrack here. My bad. Alright, I'm going to do this a little different. Sorry. Let me explain this. Let's do it like this. Let's presume for a second. I'm standing here and I'm going to shoot a gun. Okay? Now, if I shoot that gun perfectly horizontal, okay, the amount of time it takes for that bullet to hit the ground would be exactly the same as if I dropped it from the same height as where the gun is. Right? So that means that if I fire it out here perfectly horizontal and it hits the ground somewhere over here, the amount of time it's going to take is if I drop it right there. Okay? Now why is that? Well, the first thing that we need to do is we need to do one thing. We're going to neglect air resistance. We're going to neglect air resistance for right now. And actually we will do most of these questions without. But here's what's going to happen. The reason it happens is there's only one thing actually acting on the bullet. If you fire it or if you drop it. What is it?
Gravity.
Gravity. There's nothing stopping it horizontally if we ignore air resistance. The reason that the bullet stops and falls to the ground is because gravity has pulled you down. So if I drop this from this height, or I was able to throw it perfectly as hard as I wanted, doesn't matter how hard, okay, horizontal, the same amount of time it would take to drop and hit the ground. So what does that mean for us? Well, if I throw an object out from the top of a cliff, it's going to go like this and hit the ground right there. Okay? It doesn't matter how hard I throw it. Doesn't matter how hard it comes out of the gun. The time it takes to hit the ground is the same as if I drop it from the same height. So, to figure these questions out, I have to work two ways, vertically and horizontally. vertically, I treat it as if I drop that bullet. So I make V1 0. What's my acceleration? 9.8 meters per second squared. Okay? Hello? Good, good. Okay. Yeah, I'll come see you in about 5. I just gotta finish up a quick question here. Yeah, thanks. Okay, so now I need to calculate the time and how high is the cliff?
122.5 meters.
Okay, so if I can find out the amount of time it takes for it to fall as if I drop it, okay, that's the same as if I throw it horizontally out. So if I find that amount of time, I can also find out how far it is from the cliff because I threw it at 10 meters per second. So I want to find out the time. So I go delta D equals V1 delta T plus 1/2 A delta T squared. So again, we're back to these equations. I told you at the start of the year, these 5 equations are going to keep reappearing as the year goes. They're doing it again. So I have 122.5 equals 0, 1/2 9.8 times T squared. My time is the square root of 122.5 divided by 4.9. Somebody punch that into the calculator, please. Square root of 122.5 divided by 4.9. 25? 25 seconds.
No, square root it, it's 5.
Oh, I
Forgot-
missed, I
You
missed
missed
the,
square root.
yeah.
Okay, oh yeah, you just forgot the square root? Okay, so 5 seconds to hit the ground. That means then it's traveling horizontally at 10 meters per second for 5 seconds. So how far away from the cliff does it end up? 50 meters. The question is actually quite simple. Once you understand that the time it takes for it to hit the ground is the same as if you drop it. Okay? Work. Right through it, buddy. 2 more minutes, okay? Alright? Any questions about that? Again, this is stuff that we've done before. Okay. I'll go through page 173 tomorrow on that. So, you were assigned questions yesterday. Starting on page 158, right? 153, I can't remember. 158. And then there's the 340 questions. And then there's the 7 questions. Did anybody get to the 7 questions yet? Okay, you got the rest of today to do that.